Hey, I'm going to show you how to make a laser mount in ChiliPeppr, or sorry, really in Fusion 360, but then in ChiliPeppr I'll mill it out. This is the heat sink that I have. It looks like this, and I modeled it. It's not a perfect model, but it's close enough. I even got the laser in it and sort of the conical shape that the laser outputs. And then I'm going to bring in, what I'm going to do actually is I'm going to close this and I'm going to go bring my spindle holder. I modeled this a while ago, and this bracket I milled out so I have perfect accuracy of holes to attach to with a good CAD drawing. And I'm going to save this out as a different file, and I'll just call it laser holder acrylic. And I will bring in the laser diode heatsink, and you say insert into current design. That brings it in here, and then I need to align it. And so what I want to do is I just want to align it perfectly right in the middle, right in front. And so there's this little point to point where I can basically say that this line needs to line up with this line, and it will split the difference and put it right in the middle. So that looks good. It's perfectly aligned there. Let's hit OK, and then I'm going to create my acrylic piece, and you have to pick which plane you're going to draw it on, and I'm going to draw it right on this plane. And I will just, I'll pick that corner and I'll just kind of get it, you know, to something I think is reasonable. Oops, I thought I clicked. And then I know that the height is 4.2 millimeters because that's my, I'm going to make a new component. 4.2 millimeters is my thickness of the acrylic I'm using, and then I'm just going to kind of visualize how I want this to look. So I'm going to like inset it into the acrylic, and I'll show you how cool the operation is you can do. Let's just do it right where that curve starts. See, that looks off center. Yeah, maybe it's okay. I want it kind of close. I don't want too much of a ridge. Maybe this. Okay, let's go with it. Let's one last little look. All right, and it's a new component. And then if I turn off the laser, okay, so what I'm going to do now is I'm going to move the laser down a smidgen. So you just hit M for move. And I'm going to move it down into the acrylic that deep. So about 2 millimeters into it. And then I will say OK. Now I could do an operation. This is one of my favorite ones where you click the body and you say modify. And you say combine, because you're going to do a Boolean operation. You can close this now. And the target body is the stuff highlighted. The tool body will be this component. And the operation would be to cut. And when you look at the results, yeah, we'll make a new component because I'm not going to actually use it. When you turn these off, look at what you actually get. You get a perfectly cut out thing. Now that's way too much work to mill, so that's not really what I'm going to do, but it is a slick way of controlling it. So I'm going to turn that back off, turn back on my original component, and instead I'm going to project. So I'm going to create a sketch on this surface, and then I'm going to go to the project feature, which is right here, and I'm going to project, and I'm going to project these holes onto it. That should do it. So those are on my sketch now, and then I'm also going to project the diode. I don't need all of it projected. Frankly, I just need like that, because I'm just going to draw a square off of it, but I want exactness. And we'll pick that, and we'll pick that. That should give us enough to make a square. Let's turn off laser diode, and let's turn off the spindle. And now I should be able to sketch a square, and it should snap to these points. I probably could just draw a line instead. Ah, sorry. The dialogue was in the way. Okay, there's my square. Now that I look at this, though, I do want it to sort of set in tight. I may just do square, but here's what I'm thinking is I'm going to turn this back on, and I'm going to go back to project. And I'm going to turn off. Oh, yeah, see, this has to go all the way through. So I need to project one of these rings. I think that'll do it. And then I also need to project the inset right here. Let's project that line, that line, that line, and come on, let me select it. This black line. Okay. So now we will turn back on this component and turn that off. And I have all sorts of beautiful projections. Okay. Let's hit OK on the project, and then I'm going to extrude. So I know. Oh, why is it not letting me extrude? E. Oh, here. Let's cancel that and actually say stop sketch. But I still want my sketch turned on. Why is it hiding it? Is it below this layer? Huh. Weird. Let's do E. Something's not working correctly. Let's click it. And then we'll extrude. So we're going to go all the way through. So you overdo it, 6 millimeters will cut it out. And then I'm going to take the, gosh, that is just weird that it's doing that. But I'm going to take this and I'm going to extrude down 2 millimeters because I want the laser to inset. And this I want to stick up as a tab, just as sort of a tight fit inside this area. And I think that's going to be enough sort of holding force that it just rests in there and it's just gravity. We'll see. If it doesn't work, I'll make another one. Okay, now I need to go back and mill these holes. So we'll do that. We will control select. We'll hit E for extrude. And we will extrude through it. Ooh, I didn't go deep enough. Boy, it's killing me. I wonder if it's because I'm on the wrong side. No, I'm not. It's as if my sketch is like below the surface plane. Let's stop the sketch. Re-edit it. Select. E for extrude. And go all the way through. Bada bing. Okay, so now let's go mill it. The depth is probably fine right there. Okay, so to mill it, we'll save this out. And then we'll go to the cam operation. And I'm going to hit I for inspect. I want to see what my sort of narrowest. This is 1.8 millimeters, so I will presume I'm going to use, let's see what I got here. These look pretty thin. I've got some other ones. So I've got, I could use a, I know 1.69 millimeters, that's what we're going to use. is this 0.0625 inch, right? So it's a 1/16 of an inch. And that will be our end mill. So we'll do a setup. We'll say new setup, the operation, the box point. So I'm going to make this my origin. It's saying the model is 2 bodies, which is not actually what I want. So I will close that and make my model that body. The stock point will be right here. Notice the X, Y, and Z are wrong. What I want to do is we will pick a selected point. That X and Y is still wrong. So let's just say select Z and axis. So the Z is fine. Well, here, the Z plane is just anything pointing up. The X plane is just any line that you think is correct. So that looks correct to me. That's the way I like to mill. X is positive to the right, Y is positive more towards the back of your CNC machine, and we are good on that. Now the stock is important. So I know that my height is exact already, 4.2. It's just all around the edges that I'm going to have to mill. And that looks correct. So let's go with it. And then we will do a... We could do an adaptive clearing and see what this looks like. You're not supposed to do that for finishing passes, but because it's acrylic, I'm not sure I care. But my tool will be a 1/16 inch flat, which they don't give me for this roughing operation, but I'm gonna just cheat and turn off the bowl and the ball. Keep the flat, and I'll go 1/16 flat. So that's 1.59 millimeters. That is awesome. But what I will do, if they let me, can I copy and then paste the tool? And for some reason, it never lets me do that anymore. Why did I just lose my tool? Oh, here it is. So we'll just use it, and then I just have to change the feed rates because I like to run way slower. So I'm going to run at 100. I could make that an even number. And then the lead in would be 100. Lead out is 100. Ramp is 100, and the plunge needs to be half that. Okay. And then let's just hit OK and see what it does. It may do the outside. Okay, it did. But it's going to do it in one pass, and that's a problem for me. So I'm going to do the outside with a different milling job. The inside, though, I got to say, looks pretty awesome. The problem is it's not running in there, and the reason is that that default setting on adaptive leaves material. So because this doesn't have to be that precise, I may actually just say no stock to leave. You know, I think that the let's see what it does. It may even add my holes to it. When you're doing like metal work, aluminum, I think this is way more important to use this for your initial roughing pass. But on acrylic, it's pretty simple stuff. Okay, that is good, but it's still not getting in there. And again, if this is a 1.59 millimeter end mill, we're at 1.8, so we have room to get an end mill in there. That's too bad. Let's go see why. I'm a little surprised. So stock contours, let's turn off rest machining and see what that does. And you'll start to see the tool path come in as it's generating it. No, it's still not getting in there. So what I might do is we can get these no, I want to get that figured out. Let's run the preview. I'd like to show my stock, and let's run it. So it's doing the outside first, which there's just no way. So let's already change that because that's pissing me off. So the way to do that is you want to actually contain your you want to contain it. And so when you say machining boundary, you can just say silhouette and just pick that, and then your tool stays inside it. I guess inside boundary? I don't think, usually that part doesn't matter for me. Let's try that. Because we'll do a finishing pass and we'll actually leave some tabs. Okay, that looks good. Let's run that as a simulation. I'll go really fast. So it will do lots of little moves. It won't quite get in there. It's funny that it's not touching that part. We'll see how that goes. And I got it running pretty fast here. Then it will, oh, that's interesting. It's not even going into the hole. Okay, let's try a different setup where we do pocket clearing. And it's going to pick the same tool automatically. It picks the same feed rates, which is really nice. Let's just see what it does on that machining boundary. So it's finding all the pockets. It is going inside there. Oh, you know what I like to do? I like to not go down deeper than 1 millimeter on my passes. So there you go, maximum roughing step down. Oh, they're doing stock to leave, so I'll get rid of that. That's about right. There you go. It's doing everything for me. So that's probably what I'm going to go. And remember, I made that 2 millimeters deep, so it should just do it in 2 passes. And I am loving this one. So let's simulate it. We'll speed this all the way up to the max. Cool. Does another layer, then it goes into the hole, then it goes in those little bores. Awesome. I'll go with that. And then we'll do a final contour. So the contour, same tool, although I could use a thicker tool than this, but it'll probably work fine. Here's my contour. I want to leave tabs, so it knows. See how it kind of gives you a little preview. Now the height of the tabs, I'm always, 0.4. I get more aggressive and go 0.3. Sometimes I go even lighter. That should do it on that. Now, see, it's doing it with one. I mean, I appreciate the idea of using all 4.2 millimeters of this height because you're using up a lot of cutting edges, but that's pretty deep to mill because you don't get chips clearing out of there when you're basically doing a slot mill, and the acrylic really gums up easily. Okay, so we're gonna do multiple step downs. So I will do, let's see, multiple depths, maximum roughing, perfect. Do that. Awesome. Okay, let's get rid of this adaptive. It just didn't work for us. And we'll watch the whole thing now. Clears out that, clears that out, goes down the hole, mills those holes. Cool, leaves little tabs. Yeah, I think that'll work. The only thing I'm wondering is the feed rate on these. So let's go back to normal speed, roughly, and I want to watch the info. Actually, we'll go slow. maybe I'll run an error job here, but feed rate is at 100 as it goes in. So it's on a ramp. I may want to lower the ramp, although that does look, it possibly looks reasonable. Okay, we'll just stick with it. Okay, let's post-process. We will call this laser holder acrylic, and we'll just do 1001. And then on these, you know, these are all sort of the default, but use G53. I turn that off. I just say no because I don't really care for it to use G53. I use G53, which basically means you're using G54. Use M6, yes. I do like my tool change. Although on this one doesn't matter, but who cares? I like to keep it on. So we'll hit that. The one thing I've never understood though about Fusion 360 is it never really moves to a clearance Z height, and so I always have to manually edit it. It's kind of annoying. So right here I always have to say, see how it moves right there? I think that's dangerous to move without being sure you're at a clearance height. So to that, save it. We will open up that folder. And we'll go to laser acrylic holder. Here's my Gcode. Let's get over to TinyG. ChiliPeppr workspace. Drag that in. See how it looks. Oh yeah. Looks awesome. Let's get ready to mill. Okay, I'm going to, I've got my acrylic set up. I've got my X and Y at 0 for where I'm going to mill on this acrylic, but I don't have my Z at 0, so I'm going to use a touch plate. So what I'll do is I will jog up. That puts me at 10. I was maybe a millimeter hovering above. So now I'm at 20 to make room for my touch plate. And I will attach this. And I will, by the way, I always test this. In fact, let's do this. I just do that to test it, just to make sure. It's always scary doing the touch plate. So open it up. Feed rate to probe. I don't have to go that slow, but I'll go 15. Actually, I'll go 10. And I will, the height of the plate, I think it's 18, but let's check really quick with the calipers. $18.98 is that's pretty much 19. That's funny. I remember it as 18. So 19 is the height of the touch plate, and then I'll run it, but I'm going to test. Let's get it away from the end mill. And we'll hit run. Okay, beautiful. So now I'm going to do it one more time where I run it and I touch. So that worked nice. So now we'll run it for real. Run. We'll zoom in for you there. Almost there. It touched. Okay. Whew. It is scary. I've broken end mills doing that, where it just for some reason doesn't do the electrical connection. Okay. And then it's always scary actually hitting go to 0. So I'm gonna just use this little feature and go to I don't know, 1. So we'll zoom in. It's looking like it's about 1. And we will now go to 0. I can just cheat, say go to machine 0. All right. Now if we start milling, that should, what I like to do is do that. I'll come forward 1, and then I turn the spindle on. We'll go down 0.1. Yeah, so that's good. Feels correct. And I gotta get my air going. Found that to be really important, is to get air. In fact, it's critically important, because acrylic gums up. Okay. Now, should we do this without an air job? Yeah, let's live dangerously. Spindle on. We'll set our Z higher. And we will. We're at about 10,000 RPM. We will go ahead and hit play. Tool change, pause, and unpause. So we start our milling. I am using that 1/16 inch end mill. I bought it on eBay. It's Kyocera Tools. I'm running it at 100 millimeters per minute feed rate. I always start out really conservative in my Gcode. I know I can run this much faster, but after I build up some confidence, you kind of listen for that chatter noise. I used the amazing real-time feed rate adjuster in the TinyG widget. It's that little slider at the bottom where it starts out at a 1x, and then you can kind of drag it and bump it to like a 1.5x, maybe a 2x. And then it does take a little bit for that real-time feed rate control to kick in. It's probably more like a near real-time, because it can't adjust Gcode that's already in TinyG's buffer planner. It can only adjust new lines being placed into the buffer planner, which is what it does. So you'll see here I'm milling right to the wasteboard almost exactly. That's because I used that touch plate. And then it's milling these holes here. Those came out great. And then we end up milling the outline of the board. I left those little tabs. They're like 0.3 millimeter tall, those tabs. And it was just the right amount to keep the piece held, but not be too hard to break out after the milling was done. So this final board I'm popping out here with my finger, and I love the way it came out. Everything looks perfect. All the dimensions are nice. You can just kind of scrape off those little tabs. They break off really easily. And another successful milling job. Now here it is mounted on my CNC 3040 to that aluminum bracket. Those are little M3 machine bolts, and the laser fit in there perfectly. I've actually got it turned on there, and I'll just show you a little bit of the actual lasering I did afterwards, using my new laser acrylic mount done in Fusion 360 and milled in ChiliPeppr. Thanks for watching.